I'm ready. Hello and welcome back. Our next presentation is on the subject of building solutions on trust, implementing trustworthy AI in manufacturing. I'm delighted to welcome 3 speakers from Siemens to share their thoughts with us. Shuquian Wu is Head of Artificial Intelligence at Siemens. Thibault de Assi is General Manager and Global Head of Industrial Computing. And we have Dr. Ulli Waltinger, is Head of Research Group Machine Learning. Sorry, let me repeat that. He's the Head of Research Group Machine Intelligence and Technology, and he's also the Head of Siemens AI Lab. Welcome, everyone. We're delighted to have you with us today.
Hey, everybody.
How are you all doing?
Hi, Anushka.
It's great to have you with us. We're just going to get Shuquian on as well, and I believe that she's going to be sharing the presentation. Whereabouts in the world are you all beaming in from?
So I'm dialing from the fantastic field of Bavaria, yeah, home of the breweries, home of the beer, and excited to engage with you all around the world here, actually.
Oh, fantastic. And Thibault, are you also there?
I am dialing from the same location, from this fantastic area as well.
Fantastic. Shuquian, if you can just click on the share audio and visual on the top right-hand side of the screen, and we'll be able to just get you on stage with your wonderful colleagues. Yes, fantastic. While we just wait for Shuquian, you guys have also been sponsoring part of this Inspired Mind series, so big thank you from the organizers to to Siemens, of course.
Yeah, absolutely. Thank you. I mean, I had the chance to be with you a few weeks ago, where I shared with the audience how we are helping our customers deploying AI in the manufacturing space, and we have been sharing and exchanging around challenges that the manufacturing industry is facing today, and how AI is helping them to create productivity and efficiency. I'm very happy and very glad to be here today with you, Anushka, but also with Ulli. I'm sure we're gonna have fun together.
I know, it's exciting to hear from such a diverse range of minds within the Siemens group itself, particularly because as I've been reading your sort of titles out and just understanding like how seriously AI is taken aboard and across the whole of your organization, I'm sure you've got some really deep insights to share with us today.
Yeah, for sure. So I think it's also while we waiting on our colleague, but it's I think if we're talking about AI, especially in industry, we're talking about ecosystem partners, and I think this is what you guys do an amazing job, folks here, right? Connecting bits and pieces, applied researchers, industrial competences, customer needs, entrepreneurs, and I think the Inspired AI series is fantastic to follow up, and you're doing a great job, exactly, bringing bridges together, building bridges together, and we're super honored to be here right with you.
Well, I'm delighted to hand over to you all and welcome Shuquian, who again, let me remind you, is the Head of AI at Siemens. Over to you guys.
Thanks. I had some technical problem. Now I managed to join. Could you see my screen?
No, not yet.
Okay. And now? Let me know if it works, because I don't see I just see my screen.
No, it doesn't work.
Okay. But I'm sure.
Hi, Shuquian. So just at the bottom bar of your screen, you should be able to see share screen. Let's see if we can get that going for you. There we go, you're good to go. So if you hit presentation mode, we'll be able to see the whole of the screen there. Fantastic, thanks.
Now it worked? Hello? Does it work now?
Yes,
Okay,
go ahead.
perfect.
Yes.
Oh, technology, yeah. So, hi everybody, super happy to be here and having this session with you on implementing trustworthy AI in the manufacturing industry. We are witnessing today that on one side, AI is transforming the whole manufacturing world at an ever accelerating pace. And on the other hand, that makes people really worried and uncertain. So I myself brought a lot of questions today on Thibault and on Ulli, and I guess you also. So please do let us know your thoughts, stick to the chat window, and let's have a great discussion. So, hi again, Thibault and Ulli. I myself is really excited for this topic, because how to benefit from AI, but on the other hand, managing the risk. This is really the #1 question that my customers care about. And I wondered, Thibault, what brought you here today and why are you burning for this topic?
Absolutely. And guess what, Chu and Ulli? Today, actually, there is 87% of machine learning projects. They are just at the stage of a proof of concept. They never made into production there. And what I'm excited about is how we, as a technological leader, bringing integrated hardware and software, our industry know-how, and our machine learning expertise all together to create an impact in the shop floor with artificial intelligence.
Yeah. And Ulli, what are you passionate for? What makes Trust AI so important for you?
Yeah, I actually I burn for, how do we gain actually knowledge out of large data, right? The fundament, I've always geeked about, how to gain, can we learn domain know-how, can we learn somehow expertise? And I was always then passionate, not only say like, okay, these are the research agendas that we follow along, but also can we apply it to real world problems? And real world problems, guess what? Industrial aspects are the nailing hit here on, applying it to real world problem. And that's, I guess, the biggest opportunity, making an impact on the world. And this is what I'm driving and passion for. And that means also, crystallizing and somehow demystifying, the aspect, what can be done in AI, but also somehow, how do we gain trust in technical systems that are pervasive all around the world and also on the shop floor in the industrial space.
Thanks, Ulli. I really see your passion there. You know what? At this time, I'm wondering what our audience are thinking about this topic. So folks there, let's do this, please. When I go to the next slide, I have a question for you. So please stay to the chat window and type down your answers and share thoughts with us. Ready? Let's go. What makes trust for you? Let's give you like 20 seconds to write down something.
Yeah, folks, is there anything you can share?
Anything, some words jumps to your mind in the first place.
What brings trust to you? I had a nice saying in interaction with a professor actually from Cambridge, and she said like, trust is about actually, interaction. It's about, when we experience it, right? And trust is not necessarily about transparency, but she said like, it's transaction is the main cause. I do trust my wife, to be honest, right? I'd have no clue what she does, isn't it? Yeah, and we get it already, right? Transparency, yes. Anushika, thanks for sharing that. Open standards. Trust we will have to build. Garrett, thanks very much for that. Mutual understanding.
And I wanna build on the mutual understanding. And actually, this is, I think, crucial in interacting with our customers and have a deep dive in the whole value chain to be able to bring machine learning technology together with process data to create an impact, and making sure that the machine learning model is behaving as expected.
Great.
Devotion,
thanks for sharing opinions.
Chemistry. Oh, thanks for sharing that. That's a pretty awesome aspect. I keep that.
So I think some of this aspect we will cover in the next 20 minutes. So let's go back to now start the journey with our Siemens guest. Ulli, how about illustrating the power of industry AI by giving us an overview? Where is Siemens today in the industry AI?
So obviously, as old and historic, this oldest startup in Germany, at least, right? Siemens is as broad and as fascinating as the application areas when you think on industrial AI, right? The beauty and this is, having fun in large organizations means building networks. One of these networks, we experience right away here actually at the moment, but it's also about the network making, a difference in the application. And these have broad ranges, right? Applying machine learning to critical controllers. You're obviously driving a bit of of the autonomous driving aspect for mobility, or bridging the world of simulation and real-time performances and real-time applications together, or traditional reflex optimizing. What's the role of additive manufacturing in machine learning, right? How do we teach robotic system be more flexible in the handling the task? And obviously also industrial's case means like somehow can we force and apply machine and data analytics methodologies about quality inspection and process optimization. This is just a part of that, right? Parts of them are full-blown AI, I guess, and full-blown us in the product. And parts of that obviously are still on a track, right, where we need to go jointly together with the customers.
That's really impressive how far industry AI has gone, right? And this makes me wonder, what is so different, industry AI in comparison with, let's say, consumer AI or the AI that we know in our daily life? Thibault, I know you are working with our global customers, so could you share some thoughts from the customer perspective for this topic?
Yeah, actually today AI is embedded in our daily life. So actually with your mobile phone, you can already, with Siri, you can already find your nearest French restaurant, or even with Alexa, you can play the latest song of Katy Perry or Michael Jackson. But in the industry, for AI, the purpose is about creating impact, creating productivity, and creating efficiency. And here I'm gonna share with you some of the use cases where we are helping our clients to generate productivity and efficiency. I'm gonna start with one case coming from the automotive, from the body shop. Today, at one of our accounts, they are producing 1,200 cars per day. This represents in total 6 million welding points needed to be inspected. And actually today, ultrasonics technology is being used to inspect the welding quality on the chassis of the car. Regulators, but with this technology, we can expect only 90% of those welded points. Regulators allows automotive manufacturer with 5% failure rate. And here what we are doing, we are applying AI to improve quality detection of the welding points in the automotive space. A second use case, a fascinating use case coming from the additive manufacturing. And guess what? It takes today more than 30 hours to produce a part at one of our customers. But after 30 hours, after 2,500 layers being printed, here our customers might discover defects. And here what we are doing, we are applying a vision system that detects defects layer per layers. And when defect is being detected, a stop is being triggered to the printed machine. Operators will take out the product, remove the defects, put it back, or scrap it and trigger another production cycle. A third use case, this is coming from our bakery. So how today we are applying AI in helping bakeries to improve the quality inspection and accuracy. And guess what? At this customer, the counting of the baked item are done manually. So here what we are doing, we are applying a vision system very close to the baked item that counts accurately the number of products and sending signal to the automation, to the control, where we are leveraging our NPU chip to be able to detect if the baked product are defective or not. And here it helped also our customers to improve the inspection time and the accuracy out there. Lots of use cases I would love to share with them in our Q&A session later on if you would be interested.
That's really interesting. Can you maybe give a more detailed view of any example?
Yeah, and guess what? I want also to share with you the audience. Last time in our Q&A session, I asked you to give me one location where you want to apply AI tomorrow. That was my question. And one of the answers was the pub.
Yeah.
And actually, I mean, everyone loves beer, right? And what we are doing here, we are applying AI within the brewery industry to improve processes and to improve quality. And if we look at the overall process in the brewery, where we have raw materials, brewing, fermentation, packaging, and quality check. And this is at the end of this stage where there is a kind of a sommelier drinking the beer and associates a kind of a grades for the beer. And the grade should be on 6.8 in order that the whole package or the whole recipe is being validated. Across the overall process, different parameters might have an influence on the overall beer quality. For example, in the fermentation, the yeast type. In the brewing, the quality of the water, the pH. That can be also the quantity, the temperature, alarms, lots of parameter. And this is where, with Siemens team, they have developed a machine learning model deployed on our industrial grade hardware and run it next to the production to ensure the 6.8 grade at the end of the brewing line.
I really like this example. You know, it's perfect bridging the industrial AI and the consumer AI. At the end, you are applying AI for the industry, and it's the we in everyday life that are benefiting, right? And maybe, Ulli, do you have other aspects to add for this topic? What makes differentiate?
Yeah, beer sommelier is a great. Yeah, beer sommelier is, I guess, a great use case, right? But it also shows, right? It's not only about, machine learning is about defining objective function, what we call, right? So it means like, what is the desired output that generates value on the customer side or in a different application? And as we do in the research, right, we use a lot of Amnes data sets, web data sets, right? Because we know about it, we know all about the cats, right, on the internet and stuff like that. But if you impose that in the industrial shop floor, data is differently. There are certain KPIs and pieces of the puzzle which somehow make the difference, right? Because if you look on the web application that you see and you interact, fascinating, cool, awesome, I love it, right? We necessarily don't demand 100% accuracy here, right? If translate goes a bit wrong, I am okay with that, right? If the ranking goes a bit wrong, I'm okay with that. But if you're changing systems and processes on customer side, maybe having an impact of hundreds of thousands of euros a day, we want to have a KPI obviously towards more robustness and more explainability. And this goes along with, that we obviously need to enforce somehow what is the data actually means, right? Analyzing cats in images is obviously a bit one piece of the puzzle. Analyzing anomalies in a plethora of time series is a different one. And this goes along with the collaboration and competition, but also, joining forces with the domain know-how, our customers, and we, and all together game in order to, make an added value encapsulated in the machine learning system.
I mean, it's really easy to understand that robustness and explainability is really very important requirements here. But what I'm wondering is if you can explain a bit more, like, why is AI so fragile in the industry domain?
It's exactly these objective functions, right, that we train. If we train systems, and it maybe from real world examples, right, they're magnificently working if you want to identify certain pieces and objects in the world, and they're fueled with a lot of data, obviously. And our notion is like, if we pull in enough data in these machine learning systems that are optimized toward a single task, like object identification, explain what is happening in an image, or recommendation, it can be also a fragile beast, because guess what? Our world outside is dirty, and it's beauty, it's colorful, right? And it's diverse, and it's a good one, right? But this is obviously poses challenges, right? Obviously in real world examples, right? Obviously on the right side, a bit of with a glimpse of a fun example is, right, if a recommendation comes, instead of buying, or giving your wife, not flowers, but a paprika, I guess, we can live with that. But obviously this poses different challenges in the industrial floor.
So you have an example, like how to cope with industry environment?
Yes, one of these typical examples we are super excited also in research and applied research, but it's super relevant is it's called domain generalization, right? That means, you know, if you folks out there, you know, you train your system and you feed a lot of data in there. So let's say, you know, images of outdoor because you're keen on automotive and you're keen on bringing more autonomy, maybe on the vehicle aspects, right? You train it and then you deploy it somewhere else, right? And the car runs through deserts. Or in our case, if you train systems, you know, to detect deficits in certain factories, and we want to reapply that and you know, transfer that to other factories, are we sure? Are we aware of that this system works still? What gives us indication that this does work, that is not out of domain, right? And this is called domain generalization, a very important aspect that is currently driving trustworthiness in AI, especially industrial manufacturing.
Yeah, I mean, that really sounds like a big challenge, and I'm sure that's not only a challenge. Thibault, would you share with us some challenges that you observed that your customer are facing at the shop floor?
Absolutely. Today, there is 85% of potential assets remain unconnected yet. Our customers are asking us, how can I improve my quality inspection process? Siemens, please help me how I can reduce my scrap rate. I gave you the example before about the bakery use case. How can I decrease my production takt time? The spot welding use case. How can I reduce unnecessary rework efforts? Inspection time in the body shop. Or how can you automate manual inspection to overcome production bottleneck? We have a lot of customers that are doing manual inspection of their own parts at the end of line. So where and how we could leverage AI to gain productivity and reduce costs.
That's really a lot of challenges coming from the customer. You know, when we talk about trust, we talk about customers, but then we also talk about technology, because technology can also play a very important role here. And I'm sure, Ulli, you and your folks, you definitely have come up with brilliant innovation ideas how to apply technologies to cope with these kind of challenges. You think you can review some of this with us?
For sure, right? And as you said, folks out there, right? You know, trust is about mutual understanding. Trust is we have to build, right? The trust is devotion, right? These are all soft skills, obviously, which we know, which we need to obviously, you know, earn basically in interaction. No doubt about it. But there's also obviously aspects that technology can play a role. One part in the piece here, you know, in building that on the machine learning module. And one of the aspects that we are researching and sharing all about is also, you know, how do we train systems which, you know, can give us indication about, you know, its trustworthiness, about is it out of domain or is it in the domain, right? Can we use, you know, get some feedback? Because I guess folks out there who does neural networks and stack the layers on top of that, you know, you at the very end, you end up with the softmax. It's a probability distribution, right? It does crazy things if you apply that in out of domains, right? And can we somehow replace this softmax layer and get a, you know, an error prediction out there? How confident is an AI, let's say machine learning system, when it's applied in new domains? The other aspect is that we have is obviously, since, you know, Thibault amazingly put it already out there, we need, you know, we deal with low data, with low quantity of data sometimes. How do we gain trust not only into, like, you know, how can we use and show, you know, with little data already in systematics which not have, you know, 1,000 events that has been broken? Or, you know, because if we sell in products that are, you know, are cracking up 1,000 million times, we're not selling that for definitely, right? But still we want to gain some value, right? And this is what, you know, if we apply few shot meta learning, you know, aspects, methodologies, in order to sort of, can we get some hints and some indications, you know, that one value is already out there. A third example I brought with you is obviously involving you, involving the customer, involving actually the data science of the customers itself. And it's called active learning. Can we provide in technical systems getting feedback? One of the rationale is go fast end to end. Go from technical data integration to customer value as quick as possibly. Even though the value on machine learning system may be not optimal in tuned, but let's tune it over the time and with your interaction and with our interaction to improve it on the accuracy level so you are confident. And this is called active learning, and we apply that also on customer side. And the last bits of pieces I brought to you is obviously something a bit the big guy, I guess, or the big fella in research currently, knowledge graphs, right? Graphic structures have a beauty in terms of not only applying graph-based machine learning methodologies, but also impose some explainability aspects in there when dealing on customer sides, similar as we do it here for tier selection.
Thanks, Ulli. It's a lot of ideas and very impressive. And as we know, technology never disappoints. So we've talked about trust for customer, what trust means for technology. Now, Thibault, a question on you. What does trust mean for you? And how do you build up trust at shop floor?
Yeah, so actually today we are having a holistic approach. We are having a holistic approach at our customers. And when we help our customer in their AI journey, we really take the time. We really take the time in understanding our customer pain points. We really take the time in having a clear understanding on how their OT architecture and IT architecture are integrated together. And here I fully share the feedback from Ernst-Jan when he was referring to the transparency. So having complete transparency on the processes, on the data, this is I would say a first step. And then we are bringing our machine learning expert working closely with our partner, our Siemens hardware and software integrated, and with our industry know-how to really create an impact there. How we are doing it? Take a look at the circle there. Take a look at the left side of the circle. There is different sources of data from the PLCs, from the sensor, from the quality management system. And from there, we're going to create together with our partner a machine learning model. But guess what? This is not enough. Take a look now at the right side of the circle. We need to create a software application. We need to create a domain know-how software application that collects real-time data from the shop floor so that the trained machine learning model would be able to provide the right guidance to the manufacturing processes. But we need also dashboards. We need also that dashboard that the operator can look at it and take the right decision that would influence the throughput time of the manufacturing line. So we have a software application with a trained AI model, but this software needs to run somewhere. We need an industrial grade hardware. Leveraging our Siemens, our Siematic hardware portfolio element, this is where we're gonna run on our edge device, our domain know-how software application. But we also from Siemens, we are offering services across the all AI lifecycle management to create, to deploy, to monitor, and to retrain. And take a look here at the bottom of that slide. That could be your power plant. That could be your machine. That could be the elevator that took you up to your apartment today. On the top of it, we have the control layer. This is where with our industrial PC, with our PLC controller, that they are controlling and drive the machines, the equipment, or the whole manufacturing line. And then come our edge layer. But for us, edge is not a simple IoT gateway. For us, edge is about connectivity. For us, edge is about data and security. Security is at the heart of our product portfolio. Edge is also about machine learning and artificial intelligence. It's also about connectivity. Then come our cloud layer with our MindSphere, and here with Siemens we are leveraging our Mendix platform to help our customers and partners to create their own IoT application in an efficient way. And then we're going to have a look on the complete device ecosystem. So you can see here, this is an example of a body shop. We have the automation, we have the PLC, then we have our edge device where you have your AI and non-AI application running there. We are cloud agnostic, and then we have our edge management system. And this is a central management system for distributing application, for providing security update, for providing firmware updates, And also we have an app store enabling our partner and we Siemens, Ulli's team, to provide their own AI application on that store and enable them to distribute those applications across the whole manufacturing line.
Great, thanks, Thibault. So far, we've been seeing amazing potentials, cutting-edge technologies, a huge amount of challenges, but also great solutions. Now it's the time to throw a blick into the future. Thibault, how do you actually envision artificial intelligence in the next 5 or 7 years?
So, from a machine perspective or factory perspective, we do see a self-optimized system based on parameters coming, process parameters, product parameter, or even material data. AGVs will carry parts, detect obstacles, but also adjust optimally their routes. We do see digital twins. Those digital twins will communicate verbally, providing information to the operator, and this information would come from the IT and OT systems. Ulli spoke about graph technology. Smart assistant would suggest solutions to the operators to perform efficiently their incident encountered on the shop floor. At the end of the day, AI is a breakthrough technology in our century. AI is helping our customers to perform tasks that they were not be able to do it before. AI and machine will work together hand in hand, providing the operator with the right information, taking the right decision to create productivity and efficiency.
Thanks, Thibault. I think also we are at time now. That's really a great session. Now, before we go to the break, I would like to ask everybody, please imagine also one manufacturing branch, maybe the branch you are in, how you would like AI to transform it in the next years. Name any branch that you think AI would have this impact and write it down in the chat, and then please return to the Q&A session to continue our discussion. Thank you.
Thanks very much, everybody, for tuning in and engaging with us.
Thank you so much.
Thank you all to a beautiful team from Siemens. Now, you're all going to stick around for the Q&A. So I'm going to ask our lovely audience to click through the link that's going to be dropped into the chat in our hop-in, where our fantastic panel will be there to take some questions from you directly over audio and visual. Thank you all again so much.
Thank you.
Thank you.
Thank you. And we'll be back after this short break.